All right, here is another video on our intro to function notation stuff. So in this example, we want to look at a function that's represented by a graph and see if we can get information from the graph. And we also have an application going on here, so we want to see if we can make sense of what our values mean in the context of this problem. So the graph below shows us the function r equals f of t. So again, when we look at this, we should be remembering that that means that t is our input variable. So t's are going to go down here on the horizontal axis, which looks like it's times. R's are our output variable. So R's are going to go on the vertical axis, which appears to be flow rate. And these are related by function f, whose graph is shown. So this is a graph of function f, which pairs t values to r values. More specifically here, r equals f of t is the mean flow rate for the Arkansas River in thousands of cubic feet of water per second as a function of the time t in months since the start of the year. Okay, so this is thousands of cubic feet per second, and this is months. Oops. Okay. So, let's see. First question, we would like to find f of 7 and explain its meaning using everyday language. So again, I've given you sort of funny definitions for your variables. I've done this on purpose so that we can make sure we're really careful about this. Months are awkward in general, and especially when we measure this way, months since the start of the year. So t equals 0 is the very beginning of the year, so that's like January, beginning of January, January 1st. T equals 1 would be the end of January / beginning of February. T equals 2 is end of February, beginning of March, and so on. Okay, so if we want to find f of 7 and explain its meaning, let's just start with the f of 7 part. When I look at this, this is saying the value of my input is 7, and on a graph, inputs are on the horizontal axis. So we want to go to 7. Let me count these. 1, 2, 3, 4, 5. Okay, so we actually need to go right about in the middle there. So 7 is our input value, and we're asking what output f will pair with that. So to find that, we need to go up until we run into our graph. And our graph is saying that we should pair an input of 7 with an output right around here. Okay, so if we pay attention to our tick marks, if this is a 0.5, I believe we're looking at 0.1, 2, 3, 4, 5. So it looks like we're getting about 1.7. Okay, so if we have an output of 1.7 for an input of 7, we want to think very carefully about what that means. So 7, again, let's think about this. So this is beginning of January, February, March, April, May, June, July. So this is the very beginning of August or end of July, whichever way you want to think about this. So let's just say it this way. On August 1st, and again, months are kind of a weird unit, so I will be flexible a little bit with how you interpret that. But I do want you to catch that month 7 is beginning of August or end of July. The mean flow rate for the Arkansas River was, what did we say, 1.7? So 1,700 cubic feet per second. Okay, so that's the answer to part A. For part B, we're supposed to solve using the graph. So we're trying to figure out when f of t is equal to 2. Since 2 is now the output, I'm going to look for that on the vertical axis, on the r-axis in this case. So here is r equals 2, and it looks like we hit the graph twice. So we'll want to find both of those solutions. Looks like one is, oh, and what were these? 0.2, no, 0.4, 8, 1.2. Yeah, so those are 0.4s. Okay, so this is 5.6. And this one, it looks like it's just between 6.4 and 6.8. So let's call that about 6.6 or 7. 6.7. Okay. Explain the meaning using everyday language. Okay, so once again, what we're saying here is that the mean flow rate will equal 2,000 cubic feet per second after 5.6 or 6.7 months. So let me count that out once more to make sure I'm right. So this is beginning of January, February, March, April, May, June. So this is sort of like late June. And then 6.7 is late July. Mean flow rate is 2,000 cubic feet per second. Okay, next question. When is flow rate greatest? So we've been close to that. It looks like right on at the 6 mark, which is the very end of June / beginning of July. So I'm going to say on July 1st, or somewhere right around there. Okay, and one more question, an average rate of change. So we're supposed to calculate the average rate of change from t equals 4 to t equals 6 and then explain its meaning using everyday language. All right, so t equals 4 to t equals 6. So this is 4.4 and 6, 2.2. Okay, so we want to calculate a slope. So let's do 2.2 minus 0.4 over 6 minus 4. So we're getting a 1.8 over 2, which is 0.9. And again, you want to think of this as a slope, so we can think of it as a fraction. And the top of that fraction is going to be the change in r, since r is on the vertical axis, and the bottom of that fraction is going to be the change in t, since t is on the horizontal axis. Oops, there we go. Okay, so this is saying t is in months. The flow rate is increasing by 0.9 thousand cubic feet per second every month. So this is specifically between, let's see, what did we say this is? January, February, March, April, May, early May. So from May 1st to July 1st, the mean flow rate increased by, okay, 0.9 thousand. Let's make that 900 cubic feet per second each month on average. So from May 1st to June 1st, it increased by about 900 cubic feet per second, and then from June 1st to July 1st, it did the same. Again, not exactly that, that's an average. Basically, it increased by 1,800 cubic feet per second in 2 months, so we average that out, and this is what we get. All right, that's the end of this one. Thanks.